Darling, you sent, I know you sent.
Hey Dan, aren't you forgetting the project? The DIY lab bench power supply. Thank you, tripod. Hey, what's up, guys? I'm Dan H, and today on the project, I'm going to be taking the power supply out of this old computer, and I'm going to convert it into a lab bench power supply so I could bench test all my Jeep components before I put them back on Project Beach Jeep. So I'm going to open this thing up, and I'm going to walk you through all the steps I take into doing this conversion, and I'm going to try to explain it in the best detail that I can. So let's do it. Alright guys, so although your computer may be crashed or broken or obsolete, there's still plenty of resources in here that you could use before you actually chuck it. So I'm going to harvest the power supply and the USB ports right now to use for this project. Also, other things you should do before you actually throw out a computer, but you're going to want to make sure you take out your hard drive so no one could access any personal information you have on your computer. Alright guys, here is the power supply. You got your cooling fan, you got your on-off switch, you got your power selector, and you got your plug. So for all intents and purposes, we are going to be using 115 volts, not the 230 volts. And notice the output voltage. We have a 20 amp positive 5 volts, a 10 amp positive 12 volts. We have a secondary positive 12 volts with 13 amps, 3.3 volts with 20 amps, negative 12 volts at 0.3 amps, and a positive 5 volts, 2.5 amps on standby power. Alright, so here's a look at all the wires that come out of the back of the power supply. And here is a map that explains what they all mean. So this purple wire provides the standby power to your computer. Now the rest of it won't turn on until you press that nice shiny LED button. Now what that does is it'll connect this green wire to this black wire internally, and then the whole computer and the whole power supply will turn on. So before we do anything else, we're going to simulate that that button has been turned on by grounding the green to the black wires. So now what we're going to do is connect the pin from this green wire to a pin from a black wire, and this will complete the connection, simulating somebody turning on the power button to their computer. Gotta plug it in and flip the switch, see if it works. Alright, so now we know the power supply works and we can use it for what we want. Alright, so now that we know our power supply works, these capacitors will store their energy for a few minutes after they've been plugged in, so you're going to want to wait a little while before you start cutting into these wires after it's been powered up. It's very dangerous. So you're going to take a big chunk of this wire, and let's just say about halfway, we can cut off all these connectors because we don't need them. They are useless. Now, I just want to reiterate how dangerous these things could be. Do so at your own risk. Bye-bye. Alright, here's a good look inside this power supply. This is pretty dusty, so I'm going to dust this all out with a nice soft paintbrush. You could also use a can of compressed air. So now I'm just going to sort all these wires by color. And then if you look at the wire chart, this will explain what they all mean. Alright, so we got a bundle of black wires. These are all ground. We have a bundle of red wires. These are going to be our positive 5 volts. We have this blue wire. This is going to be our negative 12 volts. We have yellow wires. This is going to be our positive 12 volts. We have yellow wires with a black tracer. We will not be using these. And we have our orange. This is our positive 3.3 volts. And we have one brown. This is our positive 3.3 cents. So we're going to group this with the orange. Again, you have the purple wire, standby, positive 5 volts, and we're not using this gray wire. And here is the wiring diagram I made to illustrate the setup I chose and to show you the components I'm going to use. So we have the power supply, 2 USB cords, the 10 watt 30 ohm dummy load resistor, volt and ammeter, 150 ohm resistor, red LED, a 12 position rotary switch, but we're only going to be using 1 through 5. Let's see, I'm also going to need this 12 volt 20 amp switch, and I'm going to use some binding posts. I think that will be it. Alright. So I'm going to follow this diagram and try to arrange all these parts into something that fits inside this power supply. But first, let me just show you an issue I had with this switch. Okay, so I just wired up this 12 volt switch as a test to see how I'm going to power up this power supply. This is a 12 volt switch with an LED indicator light. So the problem I'm having is usually the top pin is a ground. It's usually a brass in color. The bottom two is the power supply and the source out. So what happens is when you throw the switch, it closes the circuit and it connects the two together. So what I had to do is I had to connect the ground with the green pin in order to get the power supply on. So I had to change this around a little bit, and this is what I came up with. I put the ground in the middle, and I put the green on the bottom. This will connect when the two power on. The problem is, now that it's backwards, the polarity of the LED won't turn on. So what I did was, I took the blue negative 12 volts instead of the positive 12 volts, and I made that on the ground. So it's a little backward, but it works. So based on the layout of this power supply and the location of these really tall heat sinks, I think this is going to be the setup of my power supply. So I'm going to draw it up and then cut it out.
Darling, you send me, I know you send me, darling, you send me, I know you send me, darling, you send me, darling, you send me, I know you do. 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 Send me, darling, you send me, I know you, darling, send me, darling, darling, darling.
Always wear eye protection. Safety first.
Darling, I know. Send me, darling, send me, I know. Send me, honest to do. Send me, honest to do.
Okay, so the first thing I'd like to address is the need for these dummy load resistors. You want to wire this up to the voltage that's going to give you its maximum amperage output. So for this model, it's going to be the red 5 volt. And you know this by the chart that's on the power supply, and you can see that it says 5 volts, 20 amps. These power supplies won't work to their full potential given constant voltage unless it detects something that needs the power. It's kind of like when you try to install LED turn signal lights and brake lights on your XJ Cherokee, but it doesn't work. You go through all that trouble to put in those LED bulbs, and then you go to turn on your signal, and it blinks rapidly like the bulb is out. So what's going on is your Jeep thinks there's no bulb in because the LEDs give such little resistance. It's kind of like the power supply. You need a dummy load resistor to trick your Jeep or your power supply into think it's working correctly. Alright, so I ran these wires the way I want them to go. Then I'm going to solder them on the resistor. I'm going to use some heat shrink tubing to protect the ends. And I'm going to use some thermal paste from my Xbox repairing days. You guys remember this? Who knows what that is? Put that in the comments. I'm going to use this thermal paste to sandwich on the resistor to the frame. Oh, there we go. Because it transfers heat, and I want the heat to dissipate out of the resistor into the frame of the power supply. It doesn't matter which side the positive and negative go on. Resistors have no polarity. Here comes the thermal paste. Okay, next I'm going to gather the wires that I want to use to wire up the rotary switch. So why we're using the rotary switch, we know what the voltage is, but to see the amp output, we're going to wire this up to the ammeter. You'll be able to turn the dial, and you'll be able to read the amperage on every position. Alright, so I got all the wires soldered into the rotary switch the way I want them. So let's recap. I got position 1, 3.3, the orange. Position 2, I got the 5 volt, red. Position 3, I got the yellow. This is 12 volt. Position 4, I got the standby 5 volts for the USB. And position 5, I have the 5 volt USB. So now I'm going to use the heat gun and shrink that tubing. Alright, so the output of this rotary switch is going to the yellow wire of the ammeter. Good. I'm also going to wire up the ammeter, and I'm going to use a red 5 volt. Alright, looks like our case is nice and dry. We'll go ahead and peel this tape off.
Darling, you send me, I know you.
Alright, binding posts are in place, and they're nice and firm.
Send me, I know you. Send me, honest to you. Send me.
Okay, I'm just going to make sure that I have 4 grounds to go to the ammeter, and the rest of these I'm just going to cut and heat shrink. Alright, I disconnected the prong of the connector to the ammeter, and I'm going to try to make all these 4 wires fit onto this. Now I'm going to insert this prong back into the connector for the ammeter. It clips right into place. I'm going to pop out the red one. You just depress this little tab and it slides out. Thank you. Okay, the binding posts are all hooked up. Looking good. And here is the connector for the ammeter. Alright, next I'm going to prepare the USBs. I'm going to use one for the standby 5 volts, and I'm going to use another for the red 5 volts. Okay, so this female USB port has its grounds on the right. It's got this brown power wire on the left, and in the center it's these blue and yellow wires. I'd like to be able to get my cell phone to charge on the standby 5.5 volts without turning on the whole power supply. So I'm going to short these two data pins because I know that smartphones need to communicate to their charger in order to tell it how many amps it needs to charge at. So by shorting the data wires, hopefully it'll let the phone know that it could just take however many amps it wants. We'll see if it works. If not, oh well. Alright, now I can install the LED. When I throw this thing on standby power, I want an LED to glow right at the top the standby USB power, so I know which one I can plug my cell phone into. And here is your standard LED. It's got two different length prongs on it, because LEDs have polarity. The longer prong is your anode, which goes to positive, and the shorter prong is your cathode, which goes to ground. So you could choose any LED you want, but the only thing is you need a resistor to go with your LED. If you just wire an LED without a resistor, it'll burn up. So, how do you choose the resistor? Well, that's based on the LED you chose, and it's based on the voltage you're using. And to figure it out, we're going to use this little thing called Ohm's law, which is resistance equals voltage over current. So what I need to do to determine my voltage is I'm going to have to subtract the forward voltage from the LED, which is the voltage that's required to get the LED to turn on. According to this little bag that my LED came in, the forward voltage is 2 volts. So I'm going to take this forward voltage and I'm going to subtract it from the 5 volts on my standby line. So, according to this little bag, my voltage will be 5 minus 2 equals 3. And my current is 20 milliamps. So to convert 20 milliamps into amps, you just move the decimal place over 3 spots, so it becomes 0.02 amps. So now, according to Mr. Ohm, the resistance I need will be 3 divided by 0.02, which equals 150. So I need a 150 ohm resistor. And what do you know, that's exactly what I have. And if you look closely at these resistors, you will see they all have color codes. And these color codes should be uniform throughout all resistors. You can see I have a brown band, a green band, another brown band, and a gold band. Now there's charts like this that can help you figure out what all these colors mean, but there's a great website that can help you determine the resistance values much quicker. And I'll throw the link in the description. And again, resistors don't have polarity. It doesn't matter which direction they face. It also doesn't matter if you connect the resistor to the anode or the cathode, just so long as it's connected.
I took the RV. It's a good-looking vehicle, ain't it?
Yeah, so nice parked in the driveway.
Yeah, it sure does. But don't you go fall in love with it now, because we're taking it with us when we leave here next month.
That's great. Alright, she's looking pretty good. Plug her in and test it out. Alright, this first switch should be the standby on. There we go. Red light powered up. Now we're going to power the rest of it with this switch. Beautiful. Fan starts up. Excellent. So right now we're on the 12 volt reading. Nothing's plugged in, so we have 0 amps. Beautiful. 5 volts. Now 3.3. Excellent. Now we'll check the standby voltage and the other USB. 5 volt standby and 5 volt USB. Excellent. Alright, now I'm going to label all the binding posts and select the switch. I'm going to turn the multimeter on to 12 volts. 12. Excellent. And also, just because your ammeter dial is set to display the amps reading at 12 volts, doesn't mean that your 3.3 and your 5 won't work. If this is powered on, all of these are live. The ammeter will only give you one reading at a time, so you can toggle between your voltages and get your reading. Now let's test some Jeep parts. So let's go ahead and test out this Jeep Cherokee blower motor on 5 volts. We got about 5.5 amps on the 5 volt line. Now let's test it on the 12 volt line. Change it to 12 volts. Nice. Well, that's a strong blower. Let's test some other Jeep parts. These washer fluid pumps. Bulbs. Relays. Indicator lights. And switches. Even head units. And speakers. And here's my cell phone charging on standby power. Let's see how many amps it's reading at. There we go, 0.6 amps. Pretty cool. And finally, here's how these power supplies can still hurt you. Everything's powered on. I'm going to turn off the main power. And the capacitors still retain electricity for another couple seconds. Alright guys, that's a wrap for this power supply project. This thing's going to get a ton of use over the course of Project Beach Jeep. So if you're trying this on your own and you have any questions, feel free to hit me up in the comments. Remember to like and subscribe, and I'll see you again on the next project.
I know you send me honest